Section 6.1 is about inverse circular functions. So we're going to just start off reminding ourselves, especially from algebra, about inverse functions. In a one-to-one function, each x value corresponds to only one y value, and y only corresponds to one x. So everything is paired with exactly one of the other. The domain of f is the range of the inverse, and the range of f is the domain of the inverse. So they literally just switch places. They're reflections of each other across the line y equals x. So, and here are the little steps about finding an inverse if you had a function. You replace f of x with y, and then you switch up x and y. Remember, the domains and range change. Solve for y and replace y with f inverse of x. And this is the way that might look. So here's a blue function, x cubed minus 1. Its inverse is the cube root of x plus 1. That would be this pink dotted line. And they are symmetrical, or reflections of each other, through that line y equals x. That's the black dotted line. So that's just kind of a reminder of algebra on that. So if we have inverse sine, you can see it written one of two ways. Either sine with the inverse up here, sine negative 1x, so that's inverse sine, or y equals arc sine. Same thing with cosine. So arc sine or arc cosine or arc tan, that just means the inverse. So remember that with sine, we typically would have something that does this. And so it's restricted. It only goes to -1 here and 1 on the top. We've talked about that in previous sections. Well, when you get the inverse, it's like you flip a piece of that. So now this is what the inverse looks like. You go, the range is from -pi/2 up to pi/2, and the x-intercept is at 0, and its domain is from -1 to 1. So it's just this little piece here. Same way with cosine, except it goes the opposite direction. So keep that in mind as we move forward. This little chart could be really helpful. So here's all the inverse functions and their domains and the interval that they're on and what quadrants of the unit circle they occur in. So you need to remember that inverse sine only exists in quadrant 1 and 4, and inverse cosine only in 1 and 2. So there's some important parts to reference in that little chart. Now, if you're doing it with the calculator, you want to be in radian mode, and then this says what angle has a cosecant, an arc cosecant of -3. So we have to remember that inverse sine is the same thing. So you're going to have 1 divided by -3. That would give you inverse sine, because these are reciprocals of each other. So on your calculator, you would do inverse sine 1 divided by -3, and you would get that. Let's see if we can move on. All right, let's look. Well, there's all those lines that got drawn mistakenly. Let's see if we can get through some of those. So on this one, we're going to use degree mode. We're asked for what angle has a tan of 3/2. Let's see, get that written. A tan of 3/2. So, and then we take the sine of that. So to get this part, you're saying what angle has a tan of 3/2 and the sine of that angle. So when we start to work on that, when you're on your calculator, you're going to hit second and tan, because that's what that tells us to do, and then put in 3 divided by 2 and you get 56.30, and you've got some decimals there. And so then we're taking the sine of that angle that this information in here is 56.3 degrees. When you take the sine of that, you get 0.832. Okay, the sine of that is 0.832. All right. So let's go look at our problem set and see what we're going to encounter there. Find the exact value of the real number. If it exists, do not use a calculator. So they're going to be giving us values that we should know. So this says, what is the inverse cosine of -1? And that means what angle has a cosine of -1. And if you don't remember, you want to always just draw a unit circle like this and think about that everywhere is 1 unit. So this is at 1, 0, this is 0, 1, this is -1, 0, and this is 0, -1. So, and remember that on the unit circle, your coordinate pair is cosine, sine. So where is cosine -1? It's right here, and that would be at pi. It's 180 degrees or pi. All right, let's move down. Where is tan inverse square root of 3/3? That means what angle has a tangent of square root of 3/3? Well, that's 30 degrees, and that would be pi/6. If you forget that, you've got a reference sheet with your unit circle, where you could always draw your triangle. Arctan of negative square root of 3/3. So that's the same thing. Which angle has a tangent of negative square root of 3/3? That will be negative pi/6. Arcsine of negative square root of 2/2. Well, we know that the angle that has a sine of square root of 2/2 is pi/4. And since it's negative, it's going to be negative pi/4. Arc cosine, same value. We know that's going to be pi/4. But where is cosine negative? Cosine is negative in quadrant 2 and 3. But we always have to be mindful of where inverse cosine lives. So let's go back here to our chart. So inverse cosine is only in 1 and 2. So even though we know that cosine is negative in 3, it can't live there. So we go back and we say, okay, we must be in 2. And the angle in quadrant 2 with a reference of 45 would be 135, and that's 3 pi/4. So you have to think about a few things when doing these. Inverse sine of the square root of 2, meaning what angle has a sine of square root of 2? Well, square root of 2 is a value more than 1, and so it does not exist. Its range is -1 to 1. So keep that one in mind. This thing, I don't know what that did. I think that was an error. Let me get rid of this guy. All right, use a calculator to find this one. Inverse tan of 0.7561. You want to be in degree mode because you're looking for an angle. And so second tan, put in that value, you get -37. And a lot of decimals, it says round to 4. So be sure you go to 4 decimals. Arc cosine, so you're going to do second cosine, put in that value, you get 155, and then go to 4 decimal places. inverse cosecant 5.95. Well, inverse of cosecant is sine, so you do 1 divided by sine of 5.95. Right. So when you do that in your calculator, you get 9.68 degrees. For inverse cotan on the next one, and you'll put that one in, 1 divided by tan, and put the value in, and you get 95.540358. It asked for 6 decimal places, so be sure you look at that. Number 12. Number 12 says the screen to the right shows how to define the inverse secant, cosecant, and cotan, and use this information to graph the inverse circular function. So this is what we're going to do. So if you'll follow this right here, this part is the inverse tan, and so we're going to do 1 divided by inverse tan of 3x, and then we just follow, and we have times, and in parentheses, x greater than 0, plus inverse tan of 3x plus pi times x less than 0 to see if we can match this thing. And remember that you'll find the inequality symbols under second math. That's where we get all these less than, greater than. You should come up with something that looks like that if you get it in right. So when I have it there on the calculator, can't go all the way on the screen, but it does have everything that we are supposed to have. So I think you should be able to do that one. That one's number 12. And that's the last question in the set, and hopefully that'll get you ready for the homework.